Okay, this is going to be your pre-lab for your next lab, Hess's Law lab. Okay, so we've learned that Hess's Law is equal to the combined energy for individual reactions for an overall reaction. Okay, so that's what Hess's Law is. So let's kind of have sort of a conversation about what we're going to accomplish with this lab. So the first thing is that we know that magnesium reacts with oxygen in the air to form magnesium oxide using this reaction right here. So magnesium solid plus half of oxygen makes magnesium oxide. The problem with this reaction is it takes very long for it to happen. So we're not actually going to perform this chemical reaction in the lab. What we're going to do is we are going to do other reactions, but our ultimate goal is to figure out how much of this, which is the energy, the heat being released, is actually being released. And so the heat, or the enthalpy change, is called the heat of the reaction. So our main goal for this lab is to figure out how many kilojoules of energy, or joules, is being released during the course of this reaction. Okay, and what Hess's law tells us is that we can determine the heats of reaction for reactions that cannot be measured directly. So we're not actually going to be measuring the heat loss for this reaction in its entirety. We're going to be doing two different reactions, and then one we're going to have to look up in order to figure out this enthalpy change. So in this lab, what we're actually going to be doing instead of that first equation is we're going to consider these three following reactions. We're going to do a reaction where we take magnesium solid and react it with HCl. That's equation A. We are then going to take magnesium oxide solid and react it with HCl, and that's equation B. Okay. And then we're not actually going to do the third reaction, equation C. What we're going to do is we're going to actually look up the enthalpy change for that reaction when we do our data analysis. Okay, so what we're going to do, it is possible then to express the combustion of magnesium, so this reaction right here, as an algebraic sum of equations A, B, and C. And what we know with Hess's law, what it tells us is that chemical reactions may be combined by addition, subtraction, multiplication, and division. And we'll dive a little bit deeper when we do the data analysis. So what's the purpose of this lab? So this is what we're actually going to be writing in our lab notebook, okay? So the purpose of this lab is to complete two chemical reactions. So we're going to actually do equation A and equation B to find out the overall enthalpy of magnesium solid oxygen gas that is making magnesium oxide. So we're ultimately trying to figure out how much heat is being released during the course of this reaction. The two concepts that we're focusing on for this lab that we've learned about is Hess's law and the enthalpy of a reaction. Okay, so this is the first procedure. First procedure is you're going to take a solid magnesium and you're going to cut it into two different things, because we're going to do two different reactions. We're going to have one that's 3 centimeters, one that's 4 centimeters, and then we're going to record the mass of each of those samples, right? Because we need to figure out how much energy is being released. I'm going to be setting up a calorimeter that kind of looks like this. So I'm going to have one styrofoam cup, and then I'm going to put another one inside of it. Okay, and the second one that's inside of the first one is where the chemical reaction is going to happen, right? Because we know that a calorimeter is a closed system, which means that no energy is going to be lost during the course of this reaction. And we know that because styrofoam is it's a heat holding or cold holding mechanism, right? So what we're doing here is we're trapping the energy in this system, right, in order to record a temperature change, right? And we need to remember that temperature change is different from energy change, right? We use temperature to help us solve for actually energy, right? What we're going to do next is we're going to add 15 milliliters of 1 molar HCl into the calorimeter, sorry, my gosh. And then we're going to measure the mass, right? Because we're not going to use HCl's density because it's mostly water. So what we're going to actually do is we're going to weigh the calorimeter with the HCl prior to the reaction. We'll do the reaction and then we'll weigh it after the reaction as well. We need an initial temp, right? Because we need, the temperature is going to tell us how our energy is either being absorbed or released. And we're going to add the shorter, so the 3 centimeter magnesium ribbon first, and then we're going to stir it until the magnesium is completely dissolved. And we're waiting until the temperature is constant to record our final temperature, which is what we're going to do. And then we're going to repeat those steps again, steps 4 through 7 again with our second piece of magnesium metal. Okay, second procedure. So the first procedure that we just did was equation A, so magnesium solid plus HCl. The second procedure is equation B, where we're using magnesium oxide and HCl. So again, we're going to mass the calorimeter. We're going to add 15 milliliters of 1 molar HCl, and then measure its combined mass. We are going to weigh out or measure 0.20 grams of magnesium oxide, or around 0.20 grams of magnesium oxide. Again, measure initial temperature. We're going to add and stir until temperature remains constant again, and record final temperature. And then we're going to do the same thing again. So we're doing 2 trials for each procedure. So based off of everything that I said in our procedure, this is sort of kind of what I'm getting for what I have to collect for data, right? Because ultimately, at the end of the day, if I know that I'm looking for enthalpy, which is which is the specific heat times the mass times the change in temperature, I need to make sure that I'm recording all of that information so I can calculate that, right? So I'm going to need the mass of the calorimeter for each reaction. I'm going to need the mass of the calorimeter and the HCl for each reaction. I'm going to need the mass of the magnesium for procedure 1. And I'm also going to need the magnesium oxide mass for procedure 2. And then lastly, I'm going to need initial temp and final temp for both procedures as well. Okay, so that's it for your lab prep. The next video that you'll watch is the actual lab. And then the third video will be analysis like we've done in the past. Thank you.